So today we are going to discuss about chapter 11, dual nature of radiation and matter. We all know that light is a wave, and that can be established by the fact that it can show interference. Now you know it can show interference, diffraction, diffraction, polarization. So these are some attributes of light which explain that it is basically a wave in nature. But when this basically electromagnetic this was established that light is basically electromagnetic wave, and that was given by James Maxwell Maxwell Clerk in 1860 by his famous electromagnetic electromagnetic theory. When this theory was proposed, then it was established that light is a wave. But in order to detect this electromagnetic wave in lab, another scientist, his name was Heinrich Hertz. Hertz was trying to detect it in the lab. Detect करने के चक्कर में जब he was doing some experiment, then he came across this another phenomena which is called as photoelectric effect. Photoelectric effect. Now, this photoelectric effect, unfortunately, cannot be explained on the basis of the wave nature. Wave nature से इसको हम समझा नहीं सकते थे. So that cannot be explained. The wave nature of light could not explain photoelectric effect, which is again a phenomena exhibited by light. It was later on explained by Einstein. Einstein, in his famous with his famous equation, photoelectric equation, considering that light is basically a packet of, yeah, rather discrete packet of energy called as photon. So basically, a particle nature. Discreteness is a property which is associated with particles, so this we can call as particle nature of light. So light behaves both as wave as well as particle, and that's why the term dual nature. So dual nature of radiation, and after that, in 1924, another French physicist, his name was G. Broglie, he proposed a very revolutionary theory that just like radiation, matter also matter shows shows a dual character, a dual property. So therefore, the duality of the matter, and he, with the help of this, he could propose another type of wave which is called as matter wave. Matter wave. So this is it as far as this chapter is concerned. This will fetch around 4 marks in the board examination, 4 to 5 marks in the board examination. Now in this module, what I'm going to discuss with you all is emission of electron, discovery of photoelectric effect, which was done by Heinrich Hertz in the lab. Then an experimental setup. This is a very important setup which was done with the help of done by his associate. These associates were Lenard and Helbach, and some important observations were made, and these observations later on became the laws of photoelectric effect. So we will be talking about laws of photoelectric effect. We must be aware of to a certain extent. Then Einstein equation using photon theory, Einstein equations were proposed, and then with the help of that equation, we can discuss about Planck's constant, a very important constant which was given by Max Planck. So this we will be talking about. In the second part of this module only, we will be talking about dual nature of matter, which was proposed by G. Broglie, and wavelength of matter wave. So that was further, as this was a qualitative basically qualitative theory which was given by G. Broglie, shown with the help of, although to support this qualitative theory, experimental setup, experimental support was given by various scientists like Davidson and German and Thomson. So that we will be talking about. As you all know that atom, as per the first model was given by Thomson by his famous plum pudding model. After that, Rutherford put forward his theory in which he first proposed the nucleus in an atom. So that's why Rutherford model is also called as Rutherford model of atom is also called as first nuclear model. Nuclear model. And this we know that in nucleus we have proton. There is a neutron, also neutral particle, which was discovered by James Chadwick. चैडविक ने इसको डिस्कवर किया था 1932 में, and this is proton which was around 1919. This proton was discovered in around 1919 by Rutherford himself. Rutherford himself. And electron, as you know, that revolves around the nucleus, was discovered by J.J. Thomson. J.J. Thomson in 1897. So this electron revolves around the nucleus, and the force which is responsible for this revolution is the electrostatic attractive force between electron and proton, and that force is basically providing the necessary centripetal force. Now, if you want to remove this electron, to remove, there is a certain minimum energy required. So that minimum energy required, because it is under the influence of attractive force, minimum energy required to remove electron is called work function. This is called as work function. It is called as work function, or this is also called as threshold energy. Right. So it is different for different metals, of course. There are some where the electrons are very closely bound to the nucleus and very tightly bound to the nucleus, the energy required will be more. Where there are some metals where the electrons are far from the nucleus and they are loosely bound, and therefore they are easier to remove the electron in those atoms. So work function basically, as I've just told you, it is the minimum amount of energy required by an electron to just escape from the metal surface. It is called as a work function. इसका जो symbol है normally हम use करते हैं phi naught से. Phi naught is the symbol used for this, and it is expressed in another unit of energy which is called as electron volt. Now one electron volt is actually equal to 1.6 into 10 to the power minus 19 joule. So this is another unit of energy in terms of which we will try to express. Now here there is a list of some metals, like यहाँ पे आपका start होता है cesium से and that ends at platinum. You can clearly see the amount of energy required to remove the electron from the cesium is as small as 2.14 electron volt, and that for the platinum it is as high as 5.65 electron volt. So obviously you can see that removing the electron from the platinum is much difficult than that of cesium. So cesium will lose the electron readily as compared to that of platinum. Now if you want to remove those electrons from any metal surface, you have to give this minimum amount of energy. Now this energy can be given in different forms, and that's why the electron emission which takes place from the metal surface can be of different type. All you have to do, you have to just supply that minimum energy, that is the work function phi naught, and अगर ये आपने एनर्जी उसको दे दिया तो उससे इलेक्ट्रॉन रिमूव हो जाएगा. अब सवाल ये कि ये एनर्जी हम इसको किस तरीके से दें. There are various methods of providing that energy to the metal surface. One is the thermionic emission, where you are giving that amount of energy, this amount of energy, in form of what? Thermal energy. So when it is being heated up and that energy is equal to the work function, the electron will be removed from the metal surface. So this is called as thermionic emission. The second is called as field emission. In field emission, you can see strong electric field is applied, and because of that, electrons are being pulled away from the metal surface. So this is kind of another method of removing the electron, high electric field, and that's what is called as the field emission. This is another type of emission which we are going to discuss today, and that is photoelectric effect. Here the energy, that minimum amount of energy, that work function is provided in form of what? Electromagnetic radiation. Electromagnetic radiation, to be more particular, if I talk about, it will be rather UV light, infrared, or visible light. So these are some of the, but any electromagnetic radiation of suitable energy can remove an electron from the metal surface, provided that energy is more than its work function. Now this is another type of emission method of emission of electron from the metal surface. This is called as a secondary emission. You must be wondering why it is secondary emission, because the primary electrons are the one which are high energetic particles, and they are made to strike on the metal surface, and they transfer their kinetic energy to these electrons which are removed from the metal surface. So if I talk about this metal surface, these are the some electrons at the surface, near to the surface of the metal, and there is some electron here which is a fast moving electron is made to hit upon it. It's a energetic, energetic electron, energetic electron, which is called as primary electron. Primary electron, primary electron. When they, with a very high kinetic energy, strike to this electron, that electron is emitted out from it. So this electron is called as secondary electron, and this emission is called as secondary emission. So this is what secondary emission is there. It is the emission of electrons from the metal surface when a highly energetic electron is made to incident upon it, so that it transfers its kinetic energy to the electron in the metal, removing the electron from the metal surface, and those electrons are called secondary electrons. So these are the various methods with the help of which we can remove the electron from the metal. So photoelectric effect is basically, it is a phenomenon of emission or removal of electron from the metal surface when a light or electromagnetic wave of suitable energy is made to fall on that metal surface. So that suitable energy has to have an energy which is at least more than वर्क फंक्शन. ये वर्क फंक्शन से ज़्यादा अगर एनर्जी है तो वहाँ से इलेक्ट्रॉन बाहर निकल जाएगा, ज़्यादा हो या कम से कम बराबर हो, ताकि उसको लूजन कर दे, बट इट विल नॉट मूव, बट इट हैज़ टू बी मोर देन work function, then only the electron will move out of the metal surface. So phenomena of emission of electrons from a metal surface, then electromagnetic radiation of suitable frequency or energy rather are incident on it, is called as photoelectric effect. And the electrons which are generated from the surface are called as photoelectrons, as they are generated, or rather they are emitted from the metal surface due to the light. Light means photo, so that's why electron is called as photoelectron. It should not be confused with photon. These are simply electrons which are emitted. These are basically electrons emitted or generated from metal surface. Right, so these are suitable energy is incident, electrons are emitted, and these electrons are called as photoelectrons. So that is it, photoelectric effect. It was basically first discovered by Heinrich Hertz in 1887, and when he was trying to detect an electromagnetic wave in the lab with the help of a detector, which was a loop consisting small spherical metal at the end of that loop, and when the electromagnetic wave reaches those detector, a spark was produced. So it was sometimes very difficult to get those sparks. What he did, he illuminated those metallic spheres with the help of UV light, and what he saw was that due to the UV light, when he exposed, those UV light was produced with the help of arc lamp. So when he exposed those metal spheres with the help of those UV light, it was seen that the spark was produced more readily, और भी आसानी से वहाँ पे स्पार्क प्रोड्यूस होने लगा. और इसका जो रीजन देखा गया वो ये है कि जब हम अल्ट्रा वायलेट रेज को मेटल सरफेस पे गिराते हैं तो वहाँ पे जो सरफेस के नज़दीक वाले इलेक्ट्रॉन हैं वो उस एनर्जी को एब्जॉर्ब करते हैं और उस मेटल सरफेस से आसानी से निकल जाते हैं, और जब वो आसानी से निकल जाते हैं तो अक्रॉस दोज टू या बिटवीन दोज टू मेटल स्फीयर they were producing kind of a spark. So it was first time discovered by Hertz, and after that his two associates done a lot of work in the lab. Some experimental work was done, and with the help of that, this law was that effect was explained, and the laws were made. So, photoelectric effect was basically further observed by his two associates, Halbach and Lenard. The Philip Lenard observed that when there are some experiments which they जो उन्होंने किए और उससे कुछ ऑब्जर्वेशन बनाए तो कुछ important observation I would like to tell you that Philip Lenard observed that when ultraviolet radiation were allowed to fall on the emitter plate of an evacuated glass tube enclosing two electrodes, current flows in the circuit. As soon as the ultraviolet radiation was stopped, the current flow was stopped. Now, why it was like that? It was basically when the light was made to incident on the emitter plate of that. Let me explain you. So, Renard's observation was basically Renard's observation. What he did was he took one evacuated glass tube, one evacuated glass tube, and this there were two electrodes. There were two electrodes which were put into it. Right, this two electrodes were there, and this was with the help of some small voltage that was connected to a small battery, and together with there was a kind of a micrometer, yeah, millimeter you can say. Micrometer was put. So when one of the electrodes, so this is called as emitter plate, and this is called as collector plate. So what he observed when this emitter plate was made, incident with, this was incident with ultraviolet UV light. Then what he observed that there was a deflection in the emitter. So emitter was showing some current that was called as photo current. And this current was there as long as the light was made to incident on it. The moment light was stopped falling on the emitter plate, the current also stopped. So what is the explanation to this experimental setup? The explanation was that when the light was made to incident upon emitter plate, the electron might have hit on this emitter plate and they were collected by this collector plate as it is held at positive potential. This is negative. So those electrons would have been collected by this collector plate and that would have constituted a circuit is complete and therefore a current was flowing through the emitter. But the moment UV light was stopped, इसको जो है गिराना बंद कर दिया इसके ऊपर तो जब गिरना बंद हो गया तो इसके बीच में क्या हो गया there was a gap so there was no conduction between those electrodes and therefore there was no current. तो ये सजेस्ट करता है कि there is indeed emission of electrons from the metal surface when the light of suitable frequency falls on that. Later on, this experiment was further, another experiment was given by Halbach एक्सपेरिमेंट में उन्होंने क्या किया उन्होंने जिंक रॉड लिया जिंक रॉड को उन्होंने कनेक्ट कर दिया विद दैट ऑफ electroscope as you know that is basically a device which can detect whether any body is having charge or not. So when this zinc rod was negatively charged, right, and when the light was made to incident on it, it became neutral. So जब इसके ऊपर लाइट गिराया गया जब यूवी लाइट गिराई गई तो क्या हो गया ये एक लाइट जब गिरी इसके ऊपर तो ये न्यूट्रल rod बनी न्यूट्रल हो गया मतलब there was no charge. And when this was neutral in the second case, that was the first case, and second case when it was neutral, there was no charge on neutral rod जब था और तब जब यूवी लाइट को उसके ऊपर गिराया गया तो देखा गया कि वो पॉजिटिवली चार्ज हो गया थर्ड केस में when this was positively charged and then UV light was made to fall on it, then it became more positively charged. Suggesting what? That every time the UV light was made to incident upon the zinc rod, it lost electron. Every time पहले जब वो नेगेटिवली चार्ज था इसका मतलब इट वाज हैविंग सम एक्सेस ऑफ इलेक्ट्रॉन, तो जब लाइट उसके ऊपर गिरी यूवी लाइट तो वो जो इलेक्ट्रॉन है वहां से बाहर निकल गए, और जब बाहर निकल गए तो वो न्यूट्रल बन गया बिकॉज दोज इलेक्ट्रॉन्स वर एक्सेस इन नंबर। जब वो न्यूट्रल बॉडी थी तो वहां से फिर इलेक्ट्रॉन निकले बाहर, और जब अब इलेक्ट्रॉन निकलेंगे तो क्या करेंगे, उस रॉड को पॉजिटिवली चार्ज करेंगे बिकॉज देयर इज डिफिशिएंसी ऑफ दोज इलेक्ट्रॉन। When it was already having a deficiency of electron, that means it was a positively charged rod, and then again UV light was made to strike incident on it, then again electrons were lost from the zinc rod. So जब ये फिर से जिंक रॉड से इलेक्ट्रॉन निकले तो उसने उस रॉड को और भी ज्यादा पॉजिटिव चार्ज बनाया। कुल मिलाकर ये है कि जब भी लाइट या इलेक्ट्रोमैग्नेटिक वेव ऑफ सूटेबल फ्रीक्वेंसी खींचती है तो वहां से इलेक्ट्रॉन एमिशन टेक्स प्लेस। तो ये एक कुछ ये शुरुआती दौर के एक्सपेरिमेंट थे जो शोन बाय लियोनार्ड एंड हालवॉक। हालवॉक ने इसके बाद दोनों ने मिलके एक एक्सपेरिमेंटल सेटअप बनाया, उसके बाद उन्होंने फोटोइलेक्ट्रिक इफेक्ट को स्टडी किया। सो दैट वाज इट। This is the Halbach and Leonard observation. Halbach in 1888 he connected a zinc plate to an electroscope. He observed that the zinc plate became uncharged if it was initially negatively charged. It becomes positively charged if it is initially uncharged, and when it was positively charged, and it became more positively charged when it was illuminated by ultraviolet light. Now, this is Leonard and Halbach's experimental study of photoelectric effect. Here we are going to change some parameters, and with the help of when we change those parameters, some observations will be made, and those observations will be explained with the help of some graph. And whatever outcome is there from those observations can be summarized into some laws of photoelectric effect. So let us first understand what this experiment setup is all about. This is, you can see, it is an evacuated glass tube. It is an evacuated glass tube, so no, it is perfectly vacuum. And there are two electrodes. One is acting like an emitter plate, which is it has to be photosensitive, means इसका जो वर्क फंक्शन है स्मॉल होना चाहिए, स्मॉल वर्क फंक्शन होना चाहिए इसका। as far as the light is concerned, photosensitive, आसानी से इलेक्ट्रॉन को निकलना चाहिए यहाँ से। There was another plate which is called as a collector plate, or simply it can be called as anode plate also, but I would call it as collector plate. Collector plate, right? It will be called as a collector plate. This is called as emitter plate. Emitter plate because electrons will be emitted from here. Right, there is a small window, and through which the light is made to incident upon this particular, a metal plate. This is the source of light. Source of light. Now, as far as the nature of this light is concerned, we can change several, parameters of this light. Like the intensity of this light can be changed by bringing the source closer to the window, and we can also change the, frequency of the source light by changing the by using different color from the same source, by using some filter. Some filter can be used to produce a light of a particular wavelength or a particular frequency. So we can change the frequency by using several filters, and we can also change the intensity of this source of light by moving it closer or away from the window. Right. So this is an important source here. I mean, this is an important part of this setup. Here, the two electrodes are connected with the supply. Here, this is positive and negative together with the rheostat, which can be changed to change the voltage. It is also called as a potential divider, or rather potential changer कह सकते हैं, इसे potential बदल सकते हैं हम लोग. And this potential difference can be measured with the help of this voltmeter. Voltmeter which tells us about the potential difference between these 2 points. And this micrometer which is used to detect current, small current of course. Micro का मतलब ये है कि बहुत small current यहाँ पे measure करेंगे. So microampere is used here, and this is a very special arrangement of keys. यहाँ पे जो keys हैं वो एक special arrangement है. Why it is called a special arrangement? Because it is used to change the polarity of the two electrodes, या rather two plates. These are the two plates. इनकी polarity को हम लोग इस arrangement के द्वारा change कर सकते हैं. That's why this is. So commutator plays a role of changing the polarity of these two electrodes A and C. Suppose these two keys are 1 1, 2, 3, and 4. If I close 1 and 2, if I close this and this, what will happen? This end will be connected to the positive terminal and the other end is connected to this A. So A will be positive, and you can see when connect 2, then this terminal will be negative. So if I close 1 and 2, and anode plate will be positive and cathode plate will be negative as negative potential. However, instead of that, if I close 3 and 4, by connecting 3 and 4, what is happening? This will be removed, of course. This will be removed. ये मैं इसको remove कर देता हूँ. अब 3 and 4 को मैं close करता हूँ. So when we close 3 and 4, so what happens? When we close 3 and 4, the 3 is connected to the positive and 3 का other जो end है वो किससे connected है? वो C से. So now C will be negative. C will be positive rather, and 4 जो है that is connected to the A. So this is 4 का जो दूसरा टर्मिनल है वो यहाँ पे नेगेटिव है. So by connecting 3 and 4, we can make A negative and C positive. However, if we connect 1 and 2, if I call just 1 and 2, so 1 and 2 will make A positive, C will be negative. If I close 3 and 4, then A will be negative and C will be positive. So we can change the polarity by closing this special fuse, which are called as commutator, right? So by moving the jockey, we can change the voltage, and accordingly we can find out the current. And the other two parameters which I am going to change is I can change the intensity of source light source, intensity of light source को मैं बदलूंगा. एक तो ये पैरामीटर यहाँ से बदला जाएगा और दूसरा है मैं frequency of the light source will be changed. Right, so these are the two parameters which I am going to change here. Here there are two parameters. One is the voltage is being changed by using a potential divider, and second is current. Current is measured from it. So this is called as photocurrent, and that is the applied voltage. Now let us discuss what happens. Some of the observations. So first observation is basically it is effect of intensity of light on the photocurrent. So what we observe here कि जैसे जैसे हम लोग intensity को बढ़ा रहे हैं, जैसे जैसे the source is brought closer to the window. Remember that there was a window here that was evacuated, glass tube. So when this source was brought closer, so the intensity was increasing, and what we observed that there was a micrometer was showing larger and larger current. So current was more, so it means the number of electrons which are reaching this electrode are more when the intensity of the incident light was changed. So when we change the intensity of light, the photocurrent increases. So that shows a straight line curve suggesting that photoelectric current increases linearly with the increase in intensity. That is, the number of electrons emitted depends on the intensity of the light. So that is the first observation, that the number of electrons emitted from the metal surface depends on the intensity of the incident light. Second observation was, it is a graph between voltage. You can see collector plate potential. It's basically a graph V versus I कर्व है. यहाँ पे हम लोग अप्लाइड वोल्टेज लगाते हैं, अप्लाइड वोल्टेज और वर्सेस फोटो करंट के बीच में ग्राफ स्टडी करते हैं. खास बात यह है कि यहाँ पे जो भी हम लाइट को गिराएंगे उसकी फ्रीक्वेंसी जो है वो कांस्टेंट होगी, इंटेंसिटी वेरिएबल होगी. तो फॉर डिफरेंट इंटेंसिटीज at constant frequency. So we will not change the color of light, we will not change the frequency of light, rather we will change the intensity of the incident light. Now let us understand how this graph can be studied. It is basically a graph between V versus I, where V is the applied voltage and I is the photocurrent. And as far as the light source is concerned, लाइट सोर्स की प्रॉपर्टी क्या है? लाइट सोर्स जो है वो सेम फ्रीक्वेंसी की लेंगे हम लोग, फ्रीक्वेंसी नहीं बदलेंगे, बट इंटेंसिटी विल बी चेंज फॉर डिफरेंट इंटेंसिटी. for different intensity, right? So what is happening here? I'm going to first keep the intensity fixed, same intensity, and same frequency of the incident light. So I'm not going to change, same intensity, same frequency. यहाँ से इलेक्ट्रॉन जो है क्या होंगे, वो इलेक्ट्रॉन निकलेंगे यहाँ से, and they will go in all, they will kind of create an electronic cloud. Some of the electron may reach here, and some of the electron अगर यहाँ पे पहुँच जाएंगे, तो they will constitute some current in the ammeter. So microammeter will give you some reading. तो शुरुआत हम क्या देखते हैं कि जब हम ग्राफ प्लॉट करते हैं, तो what we observe that if we apply no voltage, here the V is being applied and here I is being plotted. So when no voltage is applied, even in that case some current was there. Why this current was there? Because of the some of the electron might have moved to this plate. And after that, if you increase the voltage, अगर मैं इस वोल्टेज को यहाँ पे अब धीरे धीरे इसका वोल्टेज को मैं बढ़ाऊँ, अगर पॉजिटिव वोल्टेज रखा जाए, पॉजिटिव वोल्टेज को थोड़ा सा बढ़ाता हूँ, तो क्या होगा, ये जो इलेक्ट्रॉन इधर उधर जा रहे थे, they will all be attracted towards this plate because this will be at positive potential. So electron will be, they will be pulled towards this, and therefore the number of electrons reaching at this anode will be more, and therefore current will also, what will happen, it will increase. So current will increase. तो ग्राफ आपका जो है वो कुछ ऐसे जाता है, लेकिन हम क्या देखते हैं, थोड़ी देर के बाद वो सैचुरेट हो जाता है. तो हम कहते हैं वहां पे करंट जो है सैचुरेट हो गई, एंड दैट्स व्हाई इट इज कॉल्ड एज सैचुरेशन करंट. ये ऐसा क्यों है, ये समझते यूं कि जितने भी इलेक्ट्रॉन यहाँ पे पर सेकंड गिर रहे होंगे, दे ऑल विल बी अट्रैक्टेड बाय दिस प्लेट. So per second, whatever electrons are being emitted from this, all those electrons are being collected by the anode plate, and therefore the number of electrons reaching the anode plate will become constant, and therefore saturation current is being, वहाँ पे saturation current हो जाती है, current जो है saturate हो जाती है, अब नहीं बढ़ेगी. अब हम क्या करते हैं, यहाँ पे जो वोल्टेज लगाया हुआ है ना हमने इन दोनों प्लेट के अक्रॉस, अब इसको हमने थोड़ा सा नेगेटिव बढ़ा किया. तो पहले जीरो किया, जीरो करने के बाद अब मैं वोल्टेज को इधर बढ़ाऊंगा, तो आई मेक दिस नेगेटिव वोल्टेज एंड देन इट विल डिक्रीज. सो जब जैसे जैसे वोल्टेज डिक्रीज होगा, यानी कि ज़्यादा नेगेटिव होता जाएगा, तो हम क्या देखते हैं कि सेकंड केस में अब ये क्या हुआ, प्लेट पे यहाँ पे नेगेटिव पोटेंशियल आ गया, और यहाँ के जो इलेक्ट्रॉन सेम इंटेंसिटी और सेम फ्रीक्वेंसी की लाइट गिर रही थी, यहाँ से जो इलेक्ट्रॉन बहुत तेजी से भाग रहे थे, अब इनके ऊपर क्या होगा, काइंड ऑफ अ रिचार्जिंग फोर्स विल बी अप्लाइड बिकॉज दे विल रिपेल दोज इलेक्ट्रॉन्स, इलेक्ट्रॉन को रिपेल करेंगे. तो क्या होगा, यहाँ पे रिचार्जिंग होनी शुरू हो जाएगी, रिचार्जेशन इन इलेक्ट्रॉन. ठीक है, अभी इलेक्ट्रॉन स्लो होते जाएंगे, और जैसे जैसे मैं वोल्टेज इसको नेगेटिव वाले को बढ़ाता जाऊंगा, वैसे वैसे क्या होगा, इनकी स्पीड कम होती जाएगी, एंड देन इवन द फास्टेस्ट इलेक्ट्रॉन विल फेल टू रीच दिस एनोड प्लेट. और जब ऐसा होगा, तो वहां पे जो मिनिमम वोल्टेज आपने लगाया, याद है, यहाँ पे जो वोल्टेज आप बढ़ाते जा रहे हो नेगेटिव डायरेक्शन में, वो जीरो के रिस्पेक्ट में कम होता जा रहा है, तो वो मिनिमम वोल्टेज जहां पर इवन द फास्टेस्ट इलेक्ट्रॉन विल फेल टू रीच द इलेक्ट्रोड प्लेट या द एनोड प्लेट इज कॉल्ड एज स्टॉपिंग पोटेंशियल. तो मान लो कि वो मिनिमम वोल्टेज जो है V0 है, तो दिस विल बी कॉल्ड एज, ये मिनिमम नेगेटिव वोल्टेज for which even the fastest electron, most energetic electron fail to reach anode plate, right? And that's why this is called as stopping potential. Or what will happen? The electron will not reach here and the current will become zero. So photo current becomes zero. Or so the stopping voltage can also be defined as that negative voltage for which there is no current in the circuit, means there is no photo current. Photo current becomes zero. तो आपका जो ग्राफ है वो जो ऐसे जा रहा है, जैसे जैसे वोल्टेज आप बढ़ाते जाओगे नेगेटिव डायरेक्शन में, हम क्या देखते हैं कि वो धीरे धीरे कम होता जाएगा, एंड देन अल्टीमेटली इट विल बिकम जीरो. ये जो वोल्टेज आपने लगाया है, इसी को हम बोलते हैं कट ऑफ और स्टॉपिंग वोल्टेज, राइट? सो दिस विल बी कॉल्ड एज कट ऑफ और स्टॉपिंग वोल्टेज. अब ये जो है याद रहे, सेम फ्रीक्वेंसी सेम इंटेंसिटी जैसा, जब ऐसा वोल्टेज लगा रहे होंगे तो क्या हो रहा होगा कि जो सबसे तेज जो इलेक्ट्रॉन था जिसके अंदर काइनेटिक एनर्जी सबसे ज्यादा थी, कह सकते हैं कि ये मैक्सिमम है, इस इलेक्ट्रॉन को भी ये जो है पोटेंशियल क्या करेगा, सम वर्क विल बी डन टू स्टॉप दिस इलेक्ट्रॉन और टू नॉट लेट इट कम टू द एनोड प्लेट. So we can see some work is being done by the anode plate, and that work will be equal to the maximum kinetic energy of the electron. So that work done is equal to, as you know, Q into V. So here the work done becomes EV naught. So you can clearly see that maximum kinetic energy of the emitter electron depends on the stopping voltage. If more stopping voltage is applied, means kinetic energy is more. If less is the, you can see the kinetic energy, maximum kinetic energy of the emitter electron depends on what? Stopping, magnitude of stopping voltage, right? So more the stopping voltage, more kinetic energy, less the stopping voltage, less kinetic energy. So that is one thing for one intensity. Now this same experiment is repeated for different intensity, frequency remaining same. So what we observe here, कि अगर मैं थोड़ी सी इंटेंसिटी बढ़ा दूं तो यहाँ पे जब कोई वोल्टेज आपने नहीं लगाया है तो यहाँ पे कुछ करंट होगी जो कि पहले के मुकाबले में ज़्यादा होगी, और जब आप वोल्टेज बढ़ाओगे तो ये धीरे से बढ़ते बढ़ते फिर ये सैचुरेट हो जाएगी, और अगर आप कम करते जाओगे तो ये कम होती जाएगी, जब वोल्टेज को नेगेटिव करोगे तो कम होती जाएगी, एंड देन अल्टीमेटली इट विल रीच टू द सेम स्टॉपिंग वोल्टेज. इसका मतलब क्या है, आपने इंटेंसिटी को बढ़ा दिया, आपने इंटेंसिटी को जो है, ये मान लो I2 है, ये I1 है, तो आपने इंटेंसिटी को बढ़ा दिया, I2 इज मोर देन I1, तो सैचुरेशन करंट तो बढ़ गई, लेकिन जब मैं इसमें स्टॉपिंग वोल्टेज की बात करता हूँ तो स्टॉपिंग वोल्टेज सेम होती है. इसका मतलब क्या है, तो स्टॉपिंग वोल्टेज सेम है, इसका मतलब काइनेटिक एनर्जी जो इलेक्ट्रॉन की वो अभी भी उतनी ही है, क्योंकि उनको रोकने की अभी भी सेम स्टॉपिंग वोल्टेज की जरूरत पड़ रही है. सो काइनेटिक एनर्जी जो इलेक्ट्रॉन की है वो इंटेंसिटी पे डिपेंड नहीं करता है. इसका मतलब जो है यहाँ पे सेम स्टॉपिंग वोल्टेज या कट ऑफ वोल्टेज फॉर different intensity. Therefore, we can say that kinetic energy, stopping voltage is related to kinetic energy. Kinetic energy, maximum kinetic energy is independent of intensity. तो ये एक इम्पॉर्टेंट ऑब्जर्वेशन आया इस ग्राफ से. और एक चीज और आपने देखी कि जैसे जैसे भी इंटेंसिटी बढ़ा रहे हैं वैसे वैसे फोटो करंट बढ़ रही है, सैचुरेशन करंट बढ़ रही है, ये तुमने पहले ग्राफ से भी निकाल लिया था. एंड therefore again you can plot for the third source of light where the intensity is even higher. The graph will go like this. But in all these cases, as long as the frequency is same, the stopping voltage is same. So that's it. This graph is shown here. अलग अलग इंटेंसिटी के लिए है, स्टॉपिंग वोल्टेज सेम है. सो मैक्सिमम काइनेटिक एनर्जी इज एक्चुअली इक्वल टू, इट इज वर्क डन बाय द कलेक्टर प्लेट in stopping those electrons. So maximum kinetic energy is actually equal to EV naught. V naught is the minimum negative potential given to the plate A, for which even the fastest electrons fail to reach that collector plate. Since the photocurrent stops or becomes zero, this recharging potential is also called the cutoff or stopping potential, right? So this is very important graph. You must understand it is between V and I for different intensity but same frequency. And next is a graph between, again it is a voltage, applied voltage versus current. It is again V versus I ग्राफ है, और यहाँ पे जो है इंटेंसिटी को कांस्टेंट रखा, सेम इंटेंसिटी, बट अब हमने क्या किया, नाउ फॉर डिफरेंट फ्रीक्वेंसी अब हम लोग बदलेंगे, तो हमने क्या देखा कि यहाँ पे फिर से जब वहाँ पे प्लेट में, जैसे अगर मैं यहाँ पे एग्जांपल देना चाहूँ, यहाँ पे जो दोनों प्लेट है, और फिर से अगर मैं यहाँ पे V को बढ़ाऊंगा, तो जैसे जैसे मैं V बढ़ाऊंगा वैसे वैसे करंट की वैल्यू बढ़ेगी, सैचुरेट हो जाएगी, करंट यहाँ पे सैचुरेट हो जाएगी, ये सैचुरेट करंट हो गई. और जब मैं करंट को, जैसे मान लीजिए मैंने क्या किया, पहले फर्स्ट केस में हमने क्या किया, सेम इंटेंसिटी एंड सेम फ्रीक्वेंसी, ये पहला केस लिया हमने न्यूवन के केस में। तो हम क्या देखते हैं कि जब यहाँ पे सैचुरेशन करंट आ गई, उसके बाद जब मैं नेगेटिव वोल्टेज से जाता हूँ तो करंट की वैल्यू कम होती जाती है, होते होते अल्टीमेटली घट के जीरो हो जाएगी। तो यहाँ पे हमने देखा कि जब न्यूवन था तो वहाँ पे स्टॉपिंग वोल्टेज की वैल्यू, जब फ्रीक्वेंसी की वैल्यू न्यूवन थी तो स्टॉपिंग वोल्टेज की वैल्यू VO1 थी, या V01 कह सकते हैं हम। उसके बाद हमने क्या किया, इस एक्सपेरिमेंट को रिपीट किया, सेम एक्सपेरिमेंट, इट इज अगेन बिटवीन V एंड I, सेम रिपीट किया, लेकिन अब हमने फ्रीक्वेंसी को चेंज कर दिया। नेक्स्ट केस में क्या किया, पहले न्यू1 के लिए V01 था, अब ये हमने न्यू2 ले लिया, और जब हम न्यू2 ले लिया, ये हमने लिया फ्रीक्वेंसी विच इज हायर देन दैट ऑफ न्यू1, ज्यादा फ्रीक्वेंसी, ज्यादा हाई फ्रीक्वेंसी प्रीवियस फ्रीक्वेंसी के मुकाबले में। तो हम क्या देखते हैं कि अब हमें ज्यादा बड़ा पोटेंशियल लगाना पड़ रहा है, मतलब हमें और भी ज्यादा वोल्टेज अप्लाई, नेगेटिव वोल्टेज लगाना पड़ेगा, जिससे कि हम उस इलेक्ट्रॉन को रोक पाएंगे। इसका मतलब अब क्या हुआ कि जो काइनेटिक एनर्जी, एज यू नो दैट EV नॉट इज इक्वल टू K मैक्सिमम होगा। तो हुआ क्या कि पहले केस में अगर काइनेटिक एनर्जी अगर EV नॉट वन था तो काइनेटिक एनर्जी वॉज K1। जब दूसरे केस में EV02 हुआ तो काइनेटिक एनर्जी भी K2 हो गई। एंड थर्ड केस में जब हमने फ्रीक्वेंसी को न्यू3 किया तो EV03 जो है वो क्या बन गया, K3 बन गया। क्लियरली ये समझा रहा है कि जो काइनेटिक एनर्जी है वो फ्रीक्वेंसी पे डिपेंडेंट है, ज्यादा से ज्यादा काइनेटिक एनर्जी के इलेक्ट्रॉन निकलेंगे अगर फ्रीक्वेंसी को हम लोग बढ़ा दें तो। सो here the observation is that for same intensity but different frequencies, different values of stopping potential, but the same value of saturation current is obtained, and kinetic energy of the emitted electron, depends on the frequency of the incident radiation. Higher is the frequency, higher will be kinetic energy. So यहाँ पे kinetic energy depends on what? Frequency of incident radiation. So this is your second graph where the graph is plotted between V and I, applied voltage and photo current के बीच में. Next graph is again an important one. It is a graph between frequency versus stopping voltage. Now ये values आपको कहाँ से मिलेंगे, stopping voltage कहाँ से मिलेगा और frequencies कहाँ से मिलेंगी, ये आपको उस एक्सपेरिमेंट में चेंज नहीं करना है, बल्कि जो ऑब्जर्वेशन ऑलरेडी आपने जो किए हैं उससे हम लेंगे। आपको याद होगा पिछला ग्राफ जो हमने लिया था, पिछला ग्राफ मैं आपको बताऊं, अगर मैं इसको आपको समझाऊं तो देखिए क्या था कि जो पिछला ग्राफ था उसमें आपने देखा था कि सेम इंटेंसिटी की लाइट के लिए सैचुरेशन करंट तो सेम है, लेकिन जब फ्रीक्वेंसी को हम लोग बढ़ाते गए तो क्या देखा कि उनका जो स्टॉपिंग वोल्टेज है V01, V02, ये जो है जैसे जैसे फ्रीक्वेंसी बढ़ाते गए वो वैसे वैसे ये बढ़ता गया। तो ये देखिए आप, जैसे जैसे फ्रीक्वेंसी एज न्यू इज increases, V0 also increases. Now this value is taken from this graph and then a graph is plotted. So for a given metal, when the graph was plotted between frequency and the stopping voltage, what we observe here that the graph was a straight line. जैसे जैसे वोल्टेज बढ़ाते गए, एक जैसे जैसे हम फ्रीक्वेंसी को बढ़ाते गए वैसे वैसे स्टॉपिंग वोल्टेज भी वैल्यू की उसकी वैल्यू देखा गया कि बढ़ती गई। फिर से मैं याद दिला दूं कि ये कहाँ से आया, ये वैल्यू दैट हैज कम फ्रॉम दिस रिजल्ट। सो हियर न्यू एंड दिस V0, ये हम यहाँ पे प्लॉट कर सकते हैं फॉर डिफरेंट वैल्यू ऑफ न्यू1, न्यू2, न्यू3, न्यू4, एंड द वैल्यू विल बी V01, V02, V03, V04 एंड सो ऑन। और इसको जब हमने यहाँ पे ग्राफ को प्लॉट किया तो ग्राफ वॉज स्ट्रेट लाइन। ये स्ट्रेट लाइन था जो वाई एक्सिस पे कहीं से, एक्स एक्सिस पे कहीं से स्टार्ट होता है। ये ग्राफ ऐसा जा रहा है। इसका मतलब कि जैसे जैसे फ्रीक्वेंसी को हम बढ़ा रहे हैं, जैसे जैसे फ्रीक्वेंसी को बढ़ा रहे हैं वैसे वैसे स्टॉपिंग वोल्टेज भी बढ़ रहा है। अब इसका उल्टा चलते हैं, तो जैसे जैसे फ्रीक्वेंसी को हम कम करेंगे वैसे वैसे स्टॉपिंग वोल्टेज भी कम होता जाएगा। फिर एक वहां पे एक मिनिमम फ्रीक्वेंसी आ जाती है जहां पे कोई भी स्टॉपिंग पोटेंशियल लगाने की जरूरत नहीं है। इसका मतलब क्या है कि वहां पे कोई भी फोटो करंट नहीं है, दैट इज देयर इज नो एमिशन ऑफ इलेक्ट्रॉन। सो दिस इज द मिनिमम फ्रीक्वेंसी, इट इज द मिनिमम, व्हाट इज दिस न्यू नॉट, इट इज द मिनिमम फ्रीक्वेंसी of what? ये frequency किसकी है? Incident light की. Minimum frequency of incident light for which there is no emission of electron. इस frequency को कहा गया, इसको कहा गया threshold frequency. इसको क्या है? Threshold frequency. So there is a observation से यहाँ से क्या मिला कि there is a certain metal, there is a certain minimum frequency, there exists a certain minimum frequency below which if the light is incident, no emission of photoelectron will take place, and that is the concept of threshold frequency. So when this graph is plotted for different metal A and metal B, you can see if the incident frequency is more than the threshold frequency, the stopping voltage has to be applied, and when it is below than that, there is no emission of electrons, and that's why this frequency is called a threshold frequency for metal A. For a frequency nu of incident radiation lower than cutoff frequency V0, no photoelectric emission is possible even if the intensity is large. This minimum cutoff frequency is called as threshold frequency, and it is different for different metals. So on the basis of this observation made from the Lenard experiment, Lenard and Halbach experiment, we come to some conclusions, and those conclusions were termed as laws of photoelectric effect. So these are the some observations. For every metal there is a certain minimum frequency called a threshold frequency below which no emission of photoelectron takes place, however high is the intensity of the incident radiation. तो चाहे जितनी ज़्यादा इंटेंसिटी हो, एमिशन नहीं होगा unless and until जो फोटोन इंसिडेंट हो रहा है उसकी फ्रीक्वेंसी एक सर्टेन मिनिमम फ्रीक्वेंसी से ज़्यादा हो, तो वो जो मिनिमम फ्रीक्वेंसी इसको हम लोग थ्रेशोल्ड फ्रीक्वेंसी बोलते हैं. जो दूसरा लॉ है वो कहता है कि जो फोटो करंट है वो डिपेंड्स ऑन द इंटेंसिटी ऑफ द इंसिडेंट रेडिएशन, मतलब वो इंटेंसिटी पे डिपेंड करता है कि कितने इलेक्ट्रॉन पर सेकंड वहाँ पे एमिट होंगे. हाउएवर इट इज इंडिपेंडेंट ऑफ व्हाट फ्रीक्वेंसी. तो कितने इलेक्ट्रॉन निकलेंगे ये फ्रीक्वेंसी बेस पर नहीं होता है, बल्कि ये डिपेंड करता है कितनी इंटेंसिटी की लाइट वहाँ पे गिर रही है. सो ये एक सेकंड लॉ है, ये पहला लॉ कह सकते हैं, ये सेकंड लॉ है. थर्ड लॉ कहता है कि फॉर द रेडिएशन ऑफ फ्रीक्वेंसी हायर देन दैट ऑफ द थ्रेशोल्ड फ्रीक्वेंसी द मैक्सिमम काइनेटिक एनर्जी ऑफ द फोटो इलेक्ट्रॉन डिपेंड्स ऑन द फ्रीक्वेंसी ऑफ द इंसिडेंट रेडिएशन. मतलब क्या है कि यहाँ पे जो काइनेटिक एनर्जी है वो फ्रीक्वेंसी पे डिपेंड करती है. काइनेटिक एनर्जी डिपेंड्स ऑन frequency of the incident light. इस पे तो डिपेंड करती है, लेकिन ये इंटेंसिटी पे डिपेंड नहीं करती. इट इज इंडिपेंडेंट ऑफ द इंटेंसिटी ऑफ द रेडिएशन. फोर्थ विच सीम्स टू बी लास्ट बट नॉट लीस्ट, इट इज वेरी इंपॉर्टेंट लॉ जो ये कहता है कि भाई फोटो इलेक्ट्रिक एमिशन जो है एकदम इंस्टेंटेनियस प्रोसेस है. ऑलमोस्ट यहाँ पे जो टाइम है वो 10⁻⁹ सेकेंड के आसपास है. तो virtually we can say that there is no time lag between incidence of light and emission of electron. Almost instantaneous process है. The moment a photon strikes the metal surface, immediately electron will be emitted out. So यहाँ पे कंडीशन है कि या तो इलेक्ट्रॉन एमिट होगा या तो एमिट नहीं होगा. अगर एमिट हो रहा है इसका मतलब अगर लाइट की फ्रीक्वेंसी more than the threshold frequency, so electron will definitely be come out of the metal surface. If it is less than that, then electron will not come out of it. So it will come out. If it comes out, it will come out immediately, instantaneously. It will come out. These are the four laws which are called as laws of photoelectric effect.